when we got licenses, we're not going to be cut off anymore. Okay, so f of x every 40 minutes, if you remember. Okay, the same question here, we're asked to find critical numbers. We're not asked to find all the rest that we found before, but I would like to anticipate the next sections of this chapter, so we'll see. Okay, so we're asked to find critical numbers. We know that critical numbers come from two sources, from f prime of x being 0, or from f prime of x being undefined. Of course, where the function exists. Okay, so my first thing I recommend do this and find the domain of this function, because that will clarify whether the function can have critical numbers coming from f prime being undefined. We should always find the domain first. Can anyone give us the domain of that function?
Should be all reals.
Of course. Thank you very much. E to 3x, remember, it's this function defined everywhere. X squared is x squared. This is never ever 0, as you see. Perfect. Good. So then I have to find f prime. For f prime, I don't really want this. I prefer this. It's up to you. It doesn't really matter. So I differentiate the first, and I get 2x times e to negative 3x, and then plus, I copy the first function. Now I have to be careful. E to a function prime is e to that function times that function prime, which is negative 3. So let's stop for a second and tell me whether this is okay. Is that okay?
Looks correct.
Perfect. So obviously I will factor out. That's the key. That's what we try to establish or practice in the previous chapter. So obviously I want this out. I want an x out as well. So maybe we want to rearrange the whole thing before we start that. That's fine. 2x e to negative 3x minus 3x squared e to negative 3x. So we cleaned it up a little bit. And now we will factor x. I can even factor negative x e to negative 3x. And let's see what is left in parentheses. So I took the negative out, I took an x out, I took this out, so obviously I still have a 3x left inside. I took x out, I took x out, and then minus and minus 2. I would rearrange the whole thing again, minus in front, x, 3x minus 2 over e to 3x. Any questions on this derivative? Any questions? Okay, well, I'm assuming you will tell me whether you have questions. So obviously f prime of x is never undefined. This is never 0. No problems. So no critical numbers coming from this. So, but f prime of x being 0, yes, it's a fraction. A fraction is 0 only when the numerator is 0. And there are two possibilities for the numerator to be 0, and these are the critical numbers of the function. Only critical numbers can turn into max min. Can, not necessarily. But if there are no critical numbers, the function cannot have max min. So the two x values are, yes, and
2/3.
Very good, awesome. The problem does not ask us to do anything else. I would like to continue. I would like to identify what type of points are these. Is that okay with you?
Yes.
Okay, so let's continue with that because we need it anyway. So why stop now in the middle? Okay, so here's x. You can invent your own table, but before you invent your own, please use this one. When we get to a later section in the book, I just want to show you that this is just a personal opinion. It's not a bad book. I'm not saying that it's a bad book. But for example, for this particular method that they present here, they show part A, B, C, D, asymptotes, etc., 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 etc. But they don't summarize this information anywhere. They show all these parts. There is no summary, but then they show you the graph. So please summarize the information somehow into a table so you can make sense of it. I don't think that this is okay. And then they come up with some table on page 316 that I have no idea. They are just, I guess, they're studying the sign of the second derivative and then whatever. So if you don't like this table, that's fine. Invent your own, but always summarize the information so you can make sense of it and eventually be able to graph it. We're not going to graph that right now. We don't have all the information. But here we just want to identify what these points represent. So we have a 0 and 2/3, and the derivative is 0 at those points. If I want to determine these, I have to put them in the graphing calculator, the function in the graphing calculator. So in y equals clear, we have x squared, and then times e, and in parentheses, please, negative 3x, unless you have a sophisticated calculator and it works without parentheses, please, parentheses. So second and table, and I want to plug in 0. That's not a problem, I know it's 0. But I want to plug in 2 divided by 3, and I get 0.06. Okay. So exactly the same thing we did before. I don't care for the value, for the sign of this. It's always positive. I don't need to study the sign. Let me copy it here. It's better. The derivative. So this is a positive number. I don't care to plug in numbers in it. But for example, here, again, this is a quadratic function with a negative leading coefficient. So it has a maximum. And it crosses at 0 and 2/3. So obviously it's negative, negative, and positive in between. Because the leading coefficient makes it have a maximum. So this is just for the purpose of studying the sign. You don't have to do this. You can just plug in -5 in this expression. I guarantee you will get negative. If you plug in 0.1 in here, you will definitely get positive, and if you plug in 10, you will get negative. So again, I know that the function has to decrease, the function has to increase, and the function has to decrease. And now I know what type of point is 0, 0 for this function. What type of point is 0, 0? Knowing that the sequence of signs, the derivative changes sign. negative, and it's 0, and it's positive. What type of point is 0, comma 0?
Would be a local minimum.
Very good. What type of point will be 2/3, 0.06?
Local maximum.
That's it. Because of the sequence, which means this. Positive, increasing, 0, and negative for the derivative. Very good. One more topic we have to look at here in this section, which is about finding max min of a function on a closed interval. Not on the entire domain. Oh, I'm so sorry. I'm in class, I'll call you later. Sorry. I kept it on my phone because sometimes students can get in and they call me, and because I can't check messages right now, emails, so my apologies. Okay, so on page 317, no, I'm sorry, my book was still there. On page 281, let's take a look at, you choose if you'd like, from 47 through 62. Page 281.
57.
57. Good. It will not be a pleasant one. And this is 2 cosine t. But we'll make it work. 2 cosine t plus sine 2t. And the interval they are giving us is 0 to pi over 2. Perfect. So we're going to get our table going. T, f prime of t, and f of t. Only between 0 and pi over 2. Good pick. So, for this particular problem, am I recording? Yes, I'm recording. First, we have to find the critical numbers. So, critical numbers, as we know, they can come from f prime of t being 0 or f prime of t being undefined. I have to check both sources. But since the function only has cosine and sine, there is no way its derivative will be undefined at any point in time. Not possible. So we know that no critical numbers will come from f prime being undefined. So let's find first of all f prime. So 2 cosine t prime is negative 2 sine t. Now I have to be careful here because it's a function inside the function. So plus sine prime, which is cosine 2t, times the inner function prime. So this is negative 2 sine t plus 2 cosine 2t. Never undefined, but we have to find solutions for f prime of t being 0. Okay, so first of all, I'm going to write the equation as negative 2 sine t plus 2 cosine 2t equals 0. And this, as I mentioned, it will be a little bit painful because, first of all, we have to remember what cosine 2t equals to. And there are 3 different identities for this. They are pretty much the same, but because they come from the same one. But if anyone remembers, cosine twice t is cosine squared t minus sine squared t. I can replace cosine squared t by 1 minus sine squared t, and then the formula becomes this, the identity. Or I can replace sine squared t by 1 minus cosine squared t, and it becomes this. I have to choose the right one for the situation. The one that only has sine in it. This one will not work. It's a good one, but it will not work, because then I will have again sine and cosine in the same equation. I don't want that. I only want one or the other. This will not work, because then I have sine and then cosine squared. This is the only one I want to use, because again it only has sine in it. So I'll have to distribute 2 to these two terms. So let me write it first again. Negative 2 sine t plus 2, and in parentheses I write this, 1 minus 2 sine squared t. And then I distribute, but I really don't want to distribute. I want to divide both sides by 2. This by 2 and this by 2. So then I have negative sine t plus 1 minus 2 sine squared t. So I divided this term by 2, and I got negative sine t. I divided this term by 2, and I got 1 minus 2 sine squared t. Again, I have to arrange it in descending order. Minus sine t plus 1. Of course, I have a negative leading coefficient. I don't like that. And now I have to factor or use the quadratic formula. If you give me the factor form, if you say, no, I don't remember how to factor this, then we can use the quadratic formula. No matter what, we have to write the two solutions. Can anyone quickly factor this for us? 2 sine t minus 1 sine t plus 1. Let's check. 2 sine squared times 2 sine t times sine t is that. Positive 2 sine t minus sine t is sine t, and negative 1 times 1 is negative 1. So then we get two solutions in sine. As I said, we needed time to solve the trigonometric equation, then find the critical numbers between 0 and pi over 2. We are not there yet. And then find f of t for those numbers, and so on and so on, if we want to do the second part. Okay, so from here, remember the unit circle. Luckily for us, we are only interested in this. Nothing else. Just the first quadrant, because that's what is given to us. Is there an angle in the first quadrant whose sine is 1/2? Oops.
I6.
Very good. Thank you very much. I'm going back. Is there an angle in the first quadrant whose sine is negative 1?
No.
Sine is negative 1 here. Sine of 3 pi over 2 is here, which is not in between 0 and pi over 2, so nothing else. Good. Okay, if I want to continue, and I have to do this now, I have to determine these three values. So when we study a function on a closed interval, we have to determine the function values at the endpoints of the interval. That is mandatory. Not the derivative, but the function value at 0 and pi over 2, respectively. So we can do this without the graphing calculator. So if I punch in 0 here for the function, what is cosine 0?
1.
Perfect. But if I punch in 0 here, how much is sine 0?
0.
Perfect. So this is 2. For pi over 6, we'll have to perform some calculations, because cosine pi over 6 is the square root of 3 over 2. And yes, we're going to calculate that in a minute, but we can easily do the pi over 2. Cosine pi over 2.
0.
Perfect. 2 times pi over 2 is pi. Sine pi.
Also 0.
Excellent. So let's just determine this one. So f of pi over 6 is 2. Cosine pi over 6 is the square root of 3 over 2 plus sine pi over 6 times 2. 2 times pi over 6 is pi over 3. And this is the square root. I jumped. So pi over 3, sine pi over 3 is not sine of the square root of 3 over 2, is of course just the square root of 3 over 2. So this is 2 plus 1, so it's 3, the square root of 3 over 2. I need to approximate this with a calculator. So 3 times the square root of 3, and everything divided by 2. 2.6. Okay. Now the problem is asking us to stop there, but I want to continue studying the sign. Obviously, you can say, can't you just tell? Do you really need to study the sign of the derivative? That's true, I can. Because from 2 to 2.6, what should the derivative be here? If the function goes from 2 to 2.6, what should the sign be of the derivative?
Positive?
Because it's increasing. Very good. From 2 to 2.6, this will be positive. But I want to check that. That's how we catch our mistakes. From 2.6 to 0, what should the derivative be? From 2.6 to 0.
Negative.
Perfect. So here is the sequence. So 2 is here, 2.6 is here, and 0 is here. What type of point is pi over 6 comma 2.6?
Local max.
And absolute. Very good. So this is local max and absolute
C.
on the given interval. What does 0 represent?
Local. Oh wait.
It can never be local at the end.
So
But
it'd be absolute min.
very good, indeed. Absolute min. Finally, what is 0 comma 2?
Thing.
Yes. Indeed, nothing. But I want us to study the sign of the derivative. Very simple. Let's put in the graphing calculator. Here's our derivative. It's very simple. We really don't need to put in the graphing calculator because at 0, this is 0 and this is 1, right? Cosine 0 is 1, so this is positive. As we expected. And when I punch in pi over 2, this is 1, so it's negative 2, and this is pi over 2 times 2 will be pi. So negative and negative, so it's definitely negative. So the function will decrease. I don't even need to put in the graphing calculator. Why I said it will take a while, because we needed time to solve the trig equation. And we had to go through an identity, we had to go back to the unit circle, and also calculate those 3 values. So I'm going to also write them here. And this is nothing. This is a absolute and local max. Look at the sequence as well, increasing, decreasing. So absolute max and local. And this one is an absolute min. This one is nothing because it's at the endpoint of the interval. It cannot be local. And it's not an absolute max or min. There are points higher and there are points lower. So that's why 0 comma 2 is absolutely nothing. But again, this is a different section of the chapter. I just wanted to prepare you, and now we know why and how this works. Good. So it was a good pick. We needed to see a problem like that anyway, so Can we continue? Do you think we need more examples? I can show you the book.
So what happens when the derivative of the function is undefined? Is that just the
Yes, it's a very good situation. Let's take a look. It's a very good question. I want to pick a problem like that, or I can make one up. Let me make one up.
We could go back to the one that we did before and just make it a minus in the denominator, just to prove the. Unless you have a different one.
That will not work because it's a very good question. Thank you so much for telling me that. So let's discuss that. Very good question. So if we go to h of p and put p minus 1 over, let's say, p squared minus 4, the domain of this function is negative infinity, negative 2, union negative 2, 2, union to infinity. The function itself is not defined at negative 2 and 2. So even if h prime is undefined, it will be at plus or minus 2, this cannot be, these two numbers cannot become critical numbers because the function is not defined there.
Okay.
It's a very good question. Thank you for asking that. Perfect question. So if the function is undefined at these points, it cannot be a critical number. But if the derivative is undefined, but the function existed at those points, then they become critical numbers. See, in other words, a function cannot have a max or a min when it's undefined. So here's a perfect example for you. It's a very simple one. Which page am I on? I'm 11. So let's say f of x equals the square root of x. I can't think of a simpler example than this. So we know the domain of this function is
all reals greater than or equal to 0.
very good, awesome. But when we find f prime, and we know what that is, it's 1 over 2 the square root of x. And, right, I know critical numbers come from f prime of x being undefined where the function is defined, and f prime of x being 0. But this is clearly never the case for this function. Where is f prime 0? Never. Because the numerator is never 0. But is this function undefined? Yes. When x is
0.
excellent. Is this a critical number? Yes. Why? Because the function is defined at 0.
Okay.
Is that better?
Yes.
Okay. So, and that's the situation, and this will become, that's why the graph of the square root of x is this. And this is what type of point?
Absolute min.
However, the absolute min, in this case, does not create a local min. But still, f prime is undefined, therefore, there is, in this case, an absolute min. Good. Other questions? Is there anything else you would like to go back to, look at those problems? You like to choose something else? Or we will continue. We continue? Would you like to choose another problem? You want me to show you the above? Find critical numbers, and then find the absolute max min, absolute. I always ask you to identify local as well, not just the absolute max min. So we chose 57. We looked at 57. If you want to choose something else, if not, we'll continue.